Okay, I think we're good to go. My name is David Mark Clements on the interwebs. I use the middle name because it makes me unique from all the other David Clementses out there. I'm going to talk to you just a little bit about my experience, how I started using React, why I started using React, and how, in a way, I was kind of kicked, dragging, and screaming into using it, and actually began to really like it. How many people in here are using React every day right now? Wow, okay. And how many people are looking into using React? Well, that's perfect. This talk is exactly targeted. Excellent. So, as I say, I'm going to talk about my experience, or I'm going to talk about a case study. But no, I think case study is a bit too much of a cold, clinical word. So, why don't we call it a journey? My journey into loving React. Well, I like the word story better. I like stories. I'm sure you like stories. So I'm going to tell you a story. Actually, I'm going to tell you two stories. One's the prequel, and one's the main feature. It's getting kind of epic. As the guy who wrote The Notebook said, every great love starts with a great story. Or as another guy put it, to hell with the facts, we need stories. So, to give you a bit of an overview of the holistic picture, several years ago I wrote a book called Cookbook. Was just doing freelance at the time, but that kind of trajectored me into this awesome company called Nearform that does a lot of JavaScript stuff, a lot of Node stuff, a lot of microservices stuff, and a lot of React stuff. And then after that, I'm still in Nearform, but I've moved into a team called the Tiger team, which is a pan-organizational team that deals with tools, quality, evangelism, pretty much everything that works across an organization from a technical perspective. But this story occurs around here while I'm working for Nearform before I'm in the Tiger team. Mostly I'm doing training at the time, still do training a lot. And for some reason I'm in Dublin, can't remember why, get a phone call. There's this company in Germany and they want someone to come along and create some kind of innovative piece of tech to get the business excited about technology. Okay, that sounds really cool. We know you don't usually do this stuff, we know you're doing training a lot, but would you be interested? Yeah, okay, so you got to go in 2 days, right? So I got to go to Germany in 2 days. Okay, let me ring my wife, sort it all out. So I go over and on the Monday, don't arrive till halfway through the Monday, don't really find out what we're actually doing until the end of Tuesday. And so that gives me, and the thing is, the things needed for a conference the following Monday. So that gives me 5 days, including the weekend, to create this thing. There's one dev, that's me. This thing needs to work definitely on iPhone and iPad, but the business is kind of it's going through a digital transformation. So a lot of them are still very much attached to their BlackBerries. So we kind of need to get it to work on BlackBerries as well, and probably Android. And also, it's got to work on a large projected screen at the front. On top of that, on the day, there's around 300 real-time mobile connections, which doesn't sound like a lot, but when you're in the room with them, it does feel like a lot. And the real-time experience had to stay consistent over a 2-hour period with really bad conference Wi-Fi and really bad mobile network. It was on a... what do you call that place? It's like a place where lots of boats are. So it was kind of out of the way, so it wasn't great signal. And the app had to load quickly. It had to feel like it was like a native app just loading up, and it had to remain responsive throughout the 2-hour conference. So those were the constraints we were dealing with, and there wasn't much time to really think. So in a sense, there was no room for mistakes, none at all. Well, maybe there was a little bit of room for mistakes. Because actually what happened was, during the event, can you see the mistake here? Wait, here it comes, hold on. Bam. As long as it was a mistake that no one noticed, it would be fine, right? And on the day, the WebSocket server actually did crash, but the way that we built the application, no one noticed because of the recovery strategies we had in place. So this was what it looked like. Basically, on a mobile view, you had just one column, and you would say, I'm excited, I'm not excited, or I'm neutral. The talk is too fast, just write too slow. The next topic should be. And then on another screen, and this is a screen you showed on the projector, you would show these levels, and they would move in real time, right? So naturally, I thought, I'll choose React. No, actually, I went with something completely different called Riot. Anyone heard of Riot? You know where I'm coming from, right? So it was like, because we only had 5 days, I didn't have time to be like, JSX, what's that? So we went with Riot I went with Riot because I was making all the decisions, because it had such a lean, small API that there wasn't a lot to learn, and it was great for building kind of responsive, fast-moving things. It's they say on their website it's a React-like user interface micro library, but it's not really. It's somewhere between Angular and React. Many people used Angular in the room before? Did you have fun? So Riot.js is only like 8.56 kilobytes, gzipped and minified. React 0.147 is 38.56 kilobytes, gzipped and minified. So, as I say, one of our constraints was it had to load really, really snappy, so every kilobyte counted. Riot has, we'll talk a little bit more about the virtual DOM later, but for those who know what a virtual DOM is, it had a semi-VDOM approach, whereby DOM elements are actually fixed in place. So rather than re-rendering whole sections of the DOM, it just tweaks pieces of the DOM and actually interacts with the DOM directly, which is kind of against what common wisdom would say, but it does kind of work. And the other thing with Riot, as opposed to React, it makes the animation parts really easy. With React, it gets kind of complicated for doing that stuff. So where Angular extends HTML with its own DSL, its own domain-specific language, it adds to HTML to provide these templating features like looping and stuff like that. React extends JavaScript, i.e. JSX, which makes way more sense because you're taking a complex language and extending it with something simple rather than taking a simple language and extending it with something complex. Riot kind of extends both in a shared execution environment. It's kind of be a bit hard to see, but essentially you would define a component like this just with HTML, but you would also, if you see the script bit down the bottom, you could also run JavaScript inside the HTML where this context or this keyword refers to the, if you like, the scope. If you know Angular, it would refer to the actual localized execution environment for that HTML. And so we're using Browserify and stuff to require another module that we pass this keyword into, which we call the scope variable here. And then we add some methods to it, fast, perfect, slow. And then I'm calling my backend API stuff where I'm saying sync, vote, fast, perfect, slow. I'm not going to talk about the backend, but there's a whole, if you look up Node Crunch, how to build real-time applications, there's like a big blog post about how we did all of the stuff. And then each of those methods that we added to the scope, which is added to this, were then available to be attached to on-click handlers inside the HTML. And that's how we hooked everything up. So Riot.js was great for rapid prototyping. Once you got your head around it, it was great. It was a small API, easy to learn, lightweight, it's fast. Goal achieved. Within those 5 days, I got the thing together, I went to the conference, I set up, I did it, it worked. It created excitement in the business, got a pat on the back, well done. And then I was supposed to go home. But they asked me to stay on and make this office site. Now, this was a slightly bigger project, and this is something that would be generating a lot of revenue in the field of millions per year. So they wanted me to build an office site. I can't go into much more detail than that. We had a short lead time, as usual. We had a tight deadline, as usual. But due to the way the business constraints were working right then and the way the environment was, we were running this as a skunkworks project, e.g. it was kind of a secret for a little while. So it was just me doing it. And naturally, like in any kind of legacy business that has sort of old tech, the back-end APIs were slow. They were built in Cobalt, and they would crash about 3 times a day, and we're talking sometimes up to 2-second response times. But it had to be fast in spite of that. So caching then, right? It had to rapidly prove profitability post-launch. There were business reasons for this, and it was really, really important that this thing performed out of the gate and started making money straight away, otherwise it was going to get killed. And it had to respond to rapidly changing business demands before and after launch. So it had to be flexible, we had to move quickly with it, and the goalposts were constantly changing throughout the project, so we had to be really, really dynamic to keep up. So flexibility was a must. We needed this rapid prototyping phase. We needed server-side rendering as well for SEO reasons, and there was literally no time for bike shedding, and this is why they started it with just me, so I made all of the initial decisions. So I went with Riot, right, because it had success with it on the former occasion, and we needed rapid prototyping. Riot can do server-side rendering, so hey, let's try it out. So we started with one dev me. Implementation progressed really, really fast. Within the first week and a half, I had something pretty much like, it needed styling and stuff, but like it was functional, it was working. And then team members started getting added to the team. And I was like, oh, there's a team member. And then I had a holiday booked, and I thought, I'll book a holiday in August, because like nothing really happens in August. This time it did. So I went on holiday for like 10 days. New team members it just was badly timed. There was a really short handover period, no time for me to document anything. I arrived back from holiday, and this is what happened. So while I was away, we hit a wall in a big way. Basically, I went away for 10 days and came back, and the project had not gone anywhere. It was in exactly the same place with 3 people working on it. So there was an issue. And the issue was really one of knowledge proliferation to the team. It was one of basically they would have to be in my head to really be able to work on it, and that was the problem we were facing. And part of that problem was also Riot. That it's not well documented. It doesn't have a big opinion about how to do things. It doesn't have demonstratable conventions. So I put those into the project as I was going, and I was loving the flexibility. But the team members were just finding it really hard to engage with it and see how things were working. We also had some slow build problems as well, but not that. I think that was related to Riot too. And the thing with Riot is you either get it or you don't. If you don't get it, it's really hard to work with. So it doesn't scale well in terms of teams. So we had 2 options. We could press on with Riot, and I could work really hard to disseminate knowledge to the team. Or we could migrate to a framework that aligns with the team's current skill set. So we went with React. Like it was the only choice that I really had, and I didn't want to, and there were reasons I disliked React, and some of these reasons were essentially to do with the way the team would try to work with it, which is like this. Everyone who's worked with React knows that you use classes to create components. I have a big problem with that. Because classes encourage object-oriented programming. And you can say, well, look, ECMAScript 6 has added classes to JavaScript, so obviously it's fine to use. Well, there's plenty of stuff in JavaScript that's in the language and it's not fine to use, like with, for instance. So I would be against object-oriented programming. And I know that when teams, particularly if they don't come from a JavaScript background, when they start using JavaScript with classes, they're going to build a JavaScript application like a Java application or like a C# application. And that means that they're going to start creating tight couplings between things that it's going to make it hard to reuse across different component trees. They're going to start maintaining state inside the components and creating these big object meshes that are going to be hard to debug. In JavaScript, you just don't have tools that are geared towards debugging a large OOP application. And they're going to create deep nested hierarchies, which are terrible for performance in JavaScript, terrible for maintenance, and you really don't have to do things that way. So that was my first thing that just completely put me off it. The next thing was JSX made me feel uncomfortable. Everyone know what JSX is? It's like essentially using XML inside JavaScript, not in a string or anything, just directly inside the language to instantiate components. Actually, I really started to like it. The way that you can describe nested tree structures works really, really nicely. I also tend to have an anti-framework mindset because of my years working with Node. It's very much modular, very much small things that do one thing well, put those together, and then the brackish residue on the top of that is your application logic. I was much more in favor of that. I didn't like the way in React 13 that React had to be a global. It goes against pretty much everything I believed in. Nevertheless, even more problems. It was bigger than Riot. It wasn't such a massive problem with this website, but still, I mean, we wanted to be as fast as possible. And it just seemed overly verbose to work with versus Riot, and the learning curve did seem quite steep. The thing was, some of the team members had already worked with React before, and I had not, so I was at a disadvantage as the leader of that team, as the leader of that project, if my knowledge is behind. So it represented a really intense period of soaking up knowledge and understanding about how this thing works. But I still chose it, and I chose it because the burden of knowledge sharing and the burden of persuading people was greater than the migration effort was going to be. And we had restricted timelines. There was no time for ego. There was no time for bike shedding. We just had to make a decision and go with it because otherwise the project would fail, and that would be on me. And I needed to make the right decision, and this was the right decision. The other thing was we were there to do a job, or Nearform was there to do a job, which was to help the teams get set up, get local hires in to replace us, and extract ourselves. So there was going to be a lot of team growth, there was going to be a lot of churn, and that was a certainty. And I chose React because I'm able to swallow my pride, okay? So out with Riot, in with React. 2.5 weeks in, we throw away the code base and we start again with React. Now we've got about 4 to 5 weeks left. So React, and I must stress this and emphasize this, React was primarily chosen for business reasons, not because of technical opinions. We didn't spend ages arguing over the minutiae of the technical aspects of React and how it worked. We chose it because it worked for the team. That was the main driving purpose of choosing React. So why did I fall in love with React then? Several reasons. As I began to use it, the virtual DOM, the way that worked, proved to be very awesome. I knew this before, I knew about the virtual DOM, and that was what made me like it, but I wanted to just use the virtual DOM without the rest of it. Unidirectional Flow, and I'll explain that in a second, and like Redux. Who's used Redux before? Are they using Redux right now? You using Redux? Yeah, man, like it is tip-top. The componentization aspect, if you look back at the Angular 1 and the old Ember, that was all about controllers and models. It was the MVC kind of style. And actually representing your application in components just felt a lot better. It felt more right. And the fact is, I found out, particularly when it came to React 14, you don't have to use classes to build React applications. I'm going to say that again. You don't have to use classes to build React applications. And also the isomorphism, the ability to do server-side rendering, essentially. And I didn't do any of this, but React Native and the ability to use React in other scenarios, because you've completely abstracted away the DOM, so you're really just thinking about how I build an application. That's very awesome. And there's a lot of skills that can be then transferred across different disciplines. So why did I love the virtual DOM? Because DOM interaction is expensive. When state changes, React performs a tree diff on objects that represent the DOM. What that means is that it figures out the minimal amount of changes that need to be made to the DOM, batches, reads, and writes together, which is a great way to ensure that the DOM doesn't start becoming a bottleneck, and then patches the DOM with those changes. All of these things, how you interact with the DOM, were known before React came along. Yes, you have to batch your read and writes. Yes, you have to make minimal changes. No, don't store state in the DOM. That's a really stupid idea, et cetera, et cetera, et cetera. But those things, as a discipline, actually doing those things is very difficult. And as an individual developer, yeah, I can do that, but we need a team to be able to do that consistently, particularly when you may be onboarding junior developers later on down the line. So the way that the virtual DOMs works is kind of like this. You have these are essentially render trees. Every time you have a class or a component that has the render function, what you return from that is JSX, which is actually a render tree. When set state or set props is called on a component, it's marked as dirty. And then at the end of a tick round the JavaScript, around the event loop, it will call the render function for all of that component and all of its subcomponents. Then it will take a look at that new subtree versus the current subtree, figure out the differences between those two trees, convert those differences into a list of instructions for patching the DOM, and then patch the DOM. This turns out to be a really, really effective way for communicating state through an application to the UI layer. It works very, very well in browsers, slightly less well on the server-side rendering side. The virtual DOM then avoids reading from the DOM, it batches writes together, and it targets specific subtree updates. If you use should component update, the lifecycle method, with that, if you've not heard of that, look that up. Particularly when you're using Redux, this works very, very well. Pure render mixin as well, all of that stuff. You can avoid rendering entire subtrees of your application when a change is made as well. So let me explain that. So if this component was to change, but you have should component update on this component saying false, then everything beneath this component, if it had some components, is saved a render call. So you would only render the right side of the tree instead. So if you're using Redux, which is essentially immutable objects, you can just compare an old object to a new object with a simple equals operator and decide whether to render that subtree, which is another reason Redux is awesome. Other Flux implementations, you may have to actually traverse the whole object and do a complete crawl through that nested object tree to see whether you should update the object, by which time you've lost any value you would have got. So the other thing that really made me like it was unidirectional flow. But to understand what I mean by unidirectional flow, let's look at multidirectional flow. All right, this is a typical MVC style flow. When I say MVC, I'm talking about client-side MVC, like the likes of Angular and Ember. And with those, you have lots of views defined, and they talk to models, and the models talk to them, and the models talk to each other. That gets really hard to scale and to actually debug what's actually going on. Unidirectional flow, which is this whole Flux pattern, is where you have your models are essentially called stores in this pattern, and you have an action, and the action is passed, which is an object that just says this is what I am and this is what I have. That gets passed to a dispatcher, which is an object that will asynchronously, like an event emitter, emit that action and cause an update to the stores. And these stores will then create render trees that will then create a patch, which is then applied to the DOM. So that feeds into the DOM layer. That's okay, but this is better. This is Redux, which is a reimagining of Flux. So with Redux, you have an action creator, which is a function that returns an object, either synchronously or it can asynchronously create dispatch objects as well, which is really important. So you can do, you can have actions that maybe fetch some state from a remote server or whatever before they dispatch their action. The action then goes to a dispatch function, which is different to being an event emitter. This all happens in a single tick and a single call stack. That dispatch function then calls a reducer, which creates a new state based on the action that was dispatched. So every time you dispatch, it creates a new object, which is the store, subdivided by namespaces according to the reducers that you define. And then that feeds into the view layer. This actually turns out to be really, really effective because instead of having asynchronous actions happening from event emitters, which again can be very tricky to trace, you have a single call stack every time you change state. There's also some really other awesome side benefits, like it's very, very easy to implement undo and redo and stuff like that. If you're interested in that, check out Redux Devtools, because it's a great example of how that works. With Redux Devtools, you can analyze your state at any point, alter it, change it, and it will update your application as per your changes. It's very, very transparent. And so, essentially, when you're using Redux, you want to centralize your state into a single store, not many stores, a single store. You don't want to have state in your components. You want to have them in that single store, because if you can do that, you can drive your whole application from a single piece of state. And that leads to some other interesting side benefits. Like if you want to create integration testing, i.e. like E2E testing, where you have a browser that emulates user clicks to see that the application is working as it should. If you use React and Redux, what you could potentially do is, instead of generating all those user clicks and stuff, which can actually be quite a brittle approach, you can just set the state for each type of user interaction, and the application will render accordingly. And then you can just test the DOM elements that are rendered, or even just test the components that are rendered. Check out React Shallow Renderer for that stuff. That's awesome too. So I love the componentization aspect, the way that you could split the interface into visual units, abstract away the DOM. And now we think about, when we're using React, we think about applications, not documents. And that's the shift that has needed to happen for a long time. Because we're talking about, the web browser was originally built for browsing documents. And then in the early 2000s, late 90s, we went into this whole Ajax revolution, where we started creating applications that were still tied to a document way of thinking. React really takes us to that next step where we don't even think about the DOM anymore. We just think about an application. And then stateless components. Components don't have to be classes. They can and should be functions. So if you make sure that your components are stateless, pure functions, that avoids holding any state in those components. And if you can avoid that, then you, like I say, you get these benefits of centralizing your state in one place in your application. They don't need to have any state at all. So this is what a stateless component looks like, and this is how we can compose components together. I just have a function called greeting, a function called header. Destructure in ES6 is really nice as well. So the props come in, and I just take the name prop for the greeting. The props come in, and I take the auth prop for the header. I render a logo something or somewhere, and then I can, depending on when we have auth, I can render the greeting function. So you can just see your JSX as essentially a function call. And we're basically putting this is an auth object. We're using the spread operator to add all the properties of the auth object to the props of greeting, and one of those properties will be a name. And then we connect that up with React Redux. I wrote a module called React Functional. So in certain cases, you may need to add lifecycle methods. You can't do that with stateless components in React 0.14. So React Functional, what it does is it allows you to use that same pattern, but you pass it to the functional function, and then you can pass an object with lifecycle methods. So that takes you full circle. You can also do refs and stuff like that with React Functional. So another reason I fell in love with React is because I saw the direction they were moving in. Midway through the project, React 0.14, they came out with stateless components. And you can see that they're trying to move away from that object-oriented approach. And finally, the reason I fell in love with React was because of isomorphism. You essentially have a client.js entry point, a server.js entry point. A request comes into the server. It talks to the React application, and we call render to string on it, and we send that out across the response. In the client, you load a view. It talks to the React application. It renders to DOM, and it shows the view in the DOM. So essentially, most of your code is the same with these two separate entry points. And that allows for a really, really nice development experience. The only thing I would say that needs to be improved in the isomorphic area for React is render to string. Render to string is a synchronous operation. Node uses something is JavaScript, so it uses something called an event loop. The event loop, if it gets blocked, i.e. if there's a synchronous operation that takes time, you're not going to answer any more requests until that synchronous operation is finished. So if you have a large application that you're rendering using render to string, your whole application will be blocked and your requests will go down to an abysmally low number. We worked with some clients on this, and we actually moved that out into a separate process to try and help them out. But then they refactored their application to Redux. We didn't do measurements on this, so we can't be absolutely sure. When they moved over to Redux, we were able to move that render to string operation back into the application, and it rendered a lot faster. I don't know exactly why, but just anecdotal. So there's also something called React render stream, something like that, that will render the React application as a stream, which means it renders asynchronously. That's definitely something to keep your eye on. The other problem with server-side rendering with React is Facebook aren't that focused on that area because they don't use it that much. So those are the challenges, but it's still definitely worth using, still definitely worth it. You just have to watch out for that stuff. The other thing as well with server-side rendering is if you have those deeply nested object structures, lots of classes, lots of components using lots of components to the nth degree, it will be slow. And you won't notice that it's slow on the client because React is really good at working around that stuff, but it will be slow on the server. So what you want is flat component hierarchies, no more than 3 tiers, and you want to go horizontal, not vertical. So everything else was the same, simply remember the application. So to round off then, the Office site, it launched exactly on time. We successfully handed over. No original team members exist, but it's still being actively maintained and developed. I don't get any questions about it, and it's from what I hear, it's showing strong business value. So goal achieved. Thanks very much. Wow. 5 minutes for questions, I guess. Yeah? Is that okay?
I totally agree with your decision of moving from Riot to React for business reasons. But as far as I understood about Riot, it features all you said about React, and you can use Redux together with Riot. So if the team was composed by yourself, would you still shift to React, or would you stick to...
If it was just me, I wouldn't have been challenged and I wouldn't have moved. I'd have still used. But I'm glad I was challenged because at some point I needed to hand over and someone else had to understand it. So like I say, it was the business reasons. There was one other problem with Riot, and I have pull requests or issues out about this. For server-side rendering, they use a val in a really bad way. And I put an issue on it. And their attitude was like, no, we like that. So that was freaking me out at the same time. That's part of the story I didn't. But the great thing about Redux, which is a really great point, is that it doesn't have to just be used with React. There's actually an Angular Redux. Also, there's this. Terminal Devtools. I've created basically something like Chrome Devtools that works in the terminal to debug Node applications. And this is built with React and Redux. There's something called React Blessed that uses a library called Blessed, which is like curses in C, to do this. Unfortunately, we have some stability issues and we have some performance issues with it, and it's partly because of React Blessed. So in this one, we're actually going to strip away React, and we're going to just use simple JavaScript, but we're going to keep the component structure and the container component architecture, and we're going to still use Redux with that. So that's going to be an interesting experiment, because for me, Redux is what made me love React. So I'm not married to React. React is more my mistress, but Redux is my best love. Yes? With Angular? Yes, it is, actually. The way that they built React was that you can actually just, it doesn't have to take over your whole application. You can create a React widget that works inside an Angular page. This is also great as well if you're wanting to upgrade one version of React to another. You can run 2 versions of React simultaneously and gradually migrate over to the other version if you have complications. So it runs in an isolated way, particularly since 0.14. So yeah, there are ways and means of doing that, and that can be an easy migration path too, by including it in an Angular application or an Ember application, or any kind of, if you're using jQuery or whatever, you can still do it.
About the server-side rendering, would you suggest to use React also for templating on the server side, or only for rendering a web app, client-side web app?
So are you saying, do you mean just on the client side?
Well, on the server side, I mean, instead, for example, of EJS or Nginx,
All right.
React,
Yes. Well, yes, that's what we did. We didn't use any template engine other than that. We did work with a client recently that were using both Mustache and React, and it was kind of messy. It wasn't the best idea. So no, I would say stick with one. My personal opinion. Did you say Babel? Oh, source mappable. Yeah, absolutely. Yeah, yeah. I mean, if you're using Babel, you've got source maps. You can jam that in there. It works fine. The debugging experience is actually really nice when you're using Redux as well, because of things like Redux Devtools. With Redux Devtools, you can, like I say, you can analyze the state. And if all you're doing is changing state, it can make it really easy to see how the application is changing. Other than that, the things happening in a single event tick can help too. Yeah, no, debugging was pretty nice. Debugging in Riot was a little bit harder than debugging in React, actually. Riot. Debugging in Angular as well is way harder than debugging in React. Absolutely. Oh, right, yeah. So when you're using JSX and Babel and stuff, you do have a round trip. About a second, but it's okay. One thing that I forgot to say was that CSS with React is a little bit not where, I don't think it's where it should be yet. We used Sass and compiled Sass to objects, and then injected those objects into components. But the thing that did that, you couldn't do that on the server side unless you built your server with Webpack, and I really didn't want to do that because really compiling on the server side, rather not if I can avoid it as much as possible. So I had to write my own parser to do the same thing server side. So CSS stuff isn't where it could be better. But yeah, in terms of the cycles, 1.5 seconds. There's things you can do to really slow that down, and you just have to kind of watch out for that. If it gets really slow, it may be that you just need to look at your build process a little bit. Or possibly the way you're writing the React application is making it slow as well. All right. Cool. Thanks very much.